Hello, so we're looking in this lesson at binomial expansion. We're looking at it for the sort of second year course, which means what we're looking at is binomial expansion when the power of n at the top here is either a fraction or a negative number. It will be in your exam a fraction or a negative number, and so you just need to use a slightly alternative version of the binomial expansion, which I've given here, and which will be given in your exam papers or your formula booklet. So just a few things to notice about the formula. You start off with a value of 1, so the form of your expansion, the bracket has to sort of follow this form. So you need to have a number 1, and then the x is the second thing. It's fine if that's a 4x or an x over 2 or anything like that, but the really important part is this part. So the first part of your, or the inside the bracket, is going to be equivalent to 1. So you can see the 1 becomes an n, that becomes an n times by n minus 1, and an n times by n minus 1, n minus 2, and that pattern repeats. Once we've got to sort of this third part here, you'll notice that you get this factorial, so 2 factorial, and then on the next one it's 3 factorial. So you can see that the next term, if we were to follow that pattern, would be n minus 1, n minus 2, n minus 3, all over 4 factorial, and then it'd be x to the power of 4 there. Most questions that I've seen only ever ask you to kind of go up to this x cubed. They don't ask you to go as far as x to the power of 4, so we're just really going to be working with this part of the formula overall in the lesson today. So here is the first example that we're going to have a look at. So it's asking you to find the first 4 terms in the binomial expansion of 1 over 1 plus x. So the question obviously states that we're looking at the binomial expansion, so it kind of gives it away. However, you need to be able to recognise that a function given in this format would be binomial expansion. So we would rewrite that as 1 plus x to the power of minus 1, which is why it's in the denominator of the fraction. So we start off there. So we've got our power, we know that it's minus 1. We've got the 1, we've got the x, so we are ready to go. So you'd start off by putting in your equation. So here's one from earlier, and then we're going to just start substituting values into there. So I can see that my first term is going to be 1. The value for n in this case, as we sort of set up here, is minus 1 times by x, plus, so again, minus 1. My next term here now, minus 1 take away 1 is minus 2, all over 2 factorial, x squared. And then my next one again, so starting with n is minus 1, so minus 1. The next term, take away 1 will be minus 2. Next one, take away 2 will be minus 3, all over 3 factorial, x cubed. So then we would just start to evaluate those for our final answer. And it only wants 4 terms, so that's my 4 terms there. So I have 1 minus x overall, plus, so in my numerator I get 2, dividing that by 2 is just going to give me x squared, 2 factorial, just as a reminder, I'll put that over here, so 2 factorial just means 2 times by 1, and 3 factorial would be 3 times by 2 times by 1, 4 factorial, you can imagine it'd be 4 times 3 times 2 times 1, but your calculator does have a button for that, so you don't need to worry too much about doing it in your head. So the next one here, I'd get in my numerator minus 6, divided by 6 in this case, so I just need to rub that bit out, because overall I'm going to get a minus x cubed. And that's the first one done. Okay, so here is a second, slightly more involved question. So the binomial expansion of 1 minus x to the power of a third, and again, just for the sake of a bit of practice, remember that that would be, it would look like this in another way, so the third root of y minus x. So we're asked to find the expansion of that up and into including the term x cubed. So that means the same as the last question we found in the first 4 terms. The second part of this question we're not going to worry about just yet, but we will have a look at that afterwards. So state the range of values of x for which the expansion is valid. So that's just kind of going back to this idea about using this equation when you've got a fractional or a negative power. So you would hopefully start off by putting down your formula. So here it is, the formula there, and then we would just go through and start to fill in the parts for the equation. So the main thing to notice here is that the 1 is fine, but I have a minus x, and my power here to start off with is 1/3. So do take care with taking away 1 each time on these. And, you know, at the end of the day, you've got your calculator to double check, and you should be double checking your work as you're going through. So, my first term is going to be 1 plus, so n, in this case is 1/3. So that is my power, so as you can say, 1/3. The x isn't just an x though, it is a minus x, so I'm going to put a minus x in here. Then on to the next part. So again, I know that my n is 1/3, n minus 1, so 1/3 take away 1 whole is minus 2/3. That's all being divided by 2 factorial, and then there I have got a minus x all squared. Next term, I've got a 1/3 times by minus 2/3. Okay, my next one then, subtracting 1 whole again, is going to be minus 5/3. All over 3 factorial x cubed. Okay, so putting all of those now into your calculator, what you should see is that you get 1 minus x over 3, or 1/3 x. It doesn't really make much of a difference how you do that. The minus here gets squared and becomes positive. However, I've got another minus here, so again I am going to have another negative here. And that's going to be x squared, overall we get over 9, or a 9th. And then the next one again, I forgot that should be a minus x there that I'm cubing. So whilst these two negatives cancel out, I do have a negative to the power of an odd number, which is overall going to give me negative. So I'm going to get minus 5 x cubed all over 81. We could go further, but the question only asked us to go as far as x cubed, so I'm going to leave it there. We're going to start to look now at the second part, so state the range of values of x for which the expansion is valid. Okay, so at the start of the question, or at the start of the video, the binomial expansion formula that I showed you, there's a footnote to it, I should say, which tells you that it's only valid, this expansion, when the modulus of x is less than 1. In this case, if we have a look at what x is inside that bracket to begin with, so this part here, we can see that that is minus x, and so all you need to write down is that the modulus of minus x is less than 1. Taking the modulus of that negative would give us that x is less than 1. And that is just a 1-mark question which they put at the end. So you're just substituting, like I say, whatever you've got in this part of the bracket and making it, or putting it within that modulus sign and making it less than 1. The next question, it might make a little bit more sense as to why they ask that. Okay, so here's another example for us to look at. Again, it's been written as a fraction, and you need to first of all rewrite it in terms of the layout for the formula for the binomial expansion. So my denominator has got 1 plus 4x squared, and we know that that could be rewritten as 1 plus 4x to the power of minus 2. So the first part of the question again, find the binomial expansion up to and including x cubed, and then it's asking us again to state the range of values of x for which the expansion is valid, but we'll deal with that later. So again, first thing I'd expect you to do, put in your formula, write it out, make sure you've written it incorrectly, and then move on to just start substituting those values. So we know that 1 is obviously the one from the start, that's fine, we've got no problem there. Our value for x, in this case, is going to be 4x, and the power that we have for n is going to start with n is minus 2. So just a case of putting those values into your equation formula. So 1 plus minus 2, 4x, plus, okay, so minus 2 minus 3, all over 2 factorial. 4x goes inside of brackets, that whole thing gets squared. And then finally, minus 2 minus 3, the next one would then be minus 4, all over 3 factorial, and then that would be 4x all cubed. So evaluating that would give 1 minus 8x plus 48x squared minus 256x cubed, and then if you wanted to, you could put sort of dot 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 to say that obviously that does continue indefinitely. So that's that question done. So the purpose of that example was just to show you how to deal with x when it has a coefficient, obviously not the negative one that we had in the previous example, but an actual value or an actual number, and that is to put it inside a set of brackets. You know, when you're squaring it, when you're cubing it there, and that'll produce values like this. If we focus on the second part of the question, so it's just coming back to, you know, when is this a valid range? So we go back to that idea that it was the modulus of x has got to be less than 1. In this example, we can see that the x term, though, is 4x. So for this to be a valid model, we'd need to just modify this slightly to include that 4. So it's the modulus of 4x is less than 1, and that means that my modulus of x is less than. So dividing both sides by 4, so the modulus of x is less than a quarter. That is when this is going to be valid. And that's all we need to do. That is a 1-mark question, not too difficult, relatively easy to do. It's just understanding that you're using that modulus and making it less than 1. Perfect, so let's have a look at the next example. Okay, final example of the video includes a secondary question, which is similar to the WJC questions that we saw last year in the sort of first year exam, or certainly in some previous examples with regards to the binomial expansion. But we'll start off with the first part. So you've got the square root of 1 minus 2x, which we would begin with rewriting that as 1 minus 2x. Hopefully you'll see that's the power of a half. And then bringing in the formula again, writing that out, and just starting to put our different bits in. So we know, obviously, 1 is 1 that we get at the start. That's not a problem. In this case, I've got minus 2x as my sort of x substitute, and this power of a half is going to be my substitute for n. So putting all of those in, 1 plus, so n is a half, x is minus 2x. Again, here on the next bit, n is a half, subtracting 1 gives me minus a half, all over 2 factorial, and then my substitution for x is minus 2x, and that gets all squared. And finally, a half, minus a half, minus 3 over 2, let me take away 1 again, over 3 factorial, and then minus 2x, all to the power of 3 there. So, moving through, we will get the following. So that would be my sort of final answer there. I've gone up to the term x cubed, evaluating all the different parts above. The question doesn't ask for it, but were the question to ask in this case, when is it valid, it is a worthwhile example to have a look at. So we looked at that idea that the modulus of x is sort of less than 1. This is an interesting one because actually what I've got for my x there is minus 2x is less than 1. And what we know about that modulus function is that it's about sort of taking that negative away and making it positive. So you could think of it in terms of a modulus of 2x is less than 1, and so the modulus of x is less than a half. I'm going to go through on Desmos and show you why this is the range where it's valid. just so you can understand where this is coming from, but you know, that is just the format that you need to follow. So let's look now at the second part of the question. So here is the second half of that question. So you've done your binomial expansion in the first part, and now it says by substituting x is equal to 0.01, find a decimal approximation to the square root of 2. So I brought my final answer from part A in here, but what I wanted to just remind you of is where that came from. So that came from us trying to find out the square root of 1 minus 2x. So that was the first 4 terms, so there we go, x cubed. That was the first 4 terms that we got when we did that expansion. And obviously it does go on afterwards, but that was just what we had initially. Now, it's asking us to find the approximation to the square root of 2. What you are going to want to achieve at some point is that your left-hand side reads as the square root of 2, and then whatever you get on your right-hand side will hopefully be what they're asking for here, a decimal value. Okay? So bearing that in mind, we are going to substitute in this 0.01 to both of those, and this is the aim, to get that left hand side to be equivalent to the square root of 2 at some point, if we can manipulate it in such a way. So on my left hand side, when I substitute in x is 0.01, I will get the square root of 1 minus 2 times 0.01. On the right hand side, I'll get 1 minus 0.01, 0.01 squared over 2, and 0.01 cubed all over 2. Just to cut through, I'll go straight to the answers for those, where you to put them into your calculator. Okay, so this is what you'd end up with. So each of those, evaluate them individually, and I, preferably would like you to write that out were it in an exam condition. So on the left hand side, the square root of 0.98 is equivalent then to, or should I say, because we're using only the first 4 terms, I guess here what I should really be using is the approximate sign, which is like the squiggly equals. So 0.9899495. Okay, currently I've still got no idea whatsoever how we're going to try and get that square root of 2 there. So let's start to look at this left hand side and play around with it a little bit. I could rewrite it as the square root of 98 over 100. So I turn it from that decimal into a fraction there. This is usually the way into the question, and that's still equivalent to this. Taking that 98 over 100 then, I'm going to take the numerator and I'm going to split it up into something times by 2 and watch as the magic unfolds. So when I take that, and this is how clever these questions are, the way that they've been designed, I'll get 49 times by 2 over 100. So is approximately equal to 0.9899495. Were I to take the square root now of what ends up being, look at that, 2 perfect square numbers there. Oh, so good. So that will give me 7 root 2 in my numerator over 10 is approximately equivalent to 0.9899495. And a little bit of rearranging, i.e. if I multiply the numerator by 10 and then divide it all through by 7 and put that into my calculator, I am going to get this decimal approximation to the square root of 2, which is going to be roughly, when I put it in, 1.414213,571. And there we have it. That is the answer to that question. Quite tricky, and it will take some practice to be able to do these, but it is completely achievable.